I'm Jim Carney.
And I'm Linda Hirsch.
And this is Edcast, a program produced and created by educators for everyone interested in education.
It is no secret that the performance of American students in mathematics is declining. International data reveal that American students are scoring lower in math than their peers in Europe and Asia. We seem destined to lose our competitive edge if we cannot produce citizens who are literate in math and science. What's gone wrong? What can be done in classrooms to improve student math abilities? Today, we'll speak with advocate Elizabeth Carson of New York City Hold to examine the programs and policies that might make a difference in math education.
And later in the program, I'll visit with some academic experts and get their opinion on the issue. But first, to the studio with Linda and her guest.
My guest today is Elizabeth Carson. She is co-founder and executive director of New York City Hold National, a nonpartisan organization created to improve the quality of mathematics education in our nation's schools. Welcome to Edcast, and thank you for joining us.
Thank you very much.
What is New York City Hold, and why did you found it?
Well, it's a coalition of parents, teachers, school board members, administrators, higher ed faculty, members of the press even, and some elected officials from time to time. And we work on various projects at the local, state, and national level to affect change in math education in the ways that we think it needs to change.
Now, you know, we opened up the program by mentioning that American students, their math scores are not keeping up internationally at all. What is not working from your perspective in math education today?
Well, fundamentally, the programs that we're using in our schools lack basic arithmetic at the elementary level. This is rather remarkable, but it has been the case for approximately 20 years. And so, regardless of what reforms we try to effect in terms of professional development or restructuring schools or lowering class size or funding, any of these attempts to reform education are not going to work if the fundamental programs, what we're teaching children, what teachers are teaching children, and what they're expected to learn is flawed. Okay. And that is the problem.
Now, you say there's not basic arithmetic. That's a pretty...
Sounds pretty amazing.
It's a pretty provocative statement, I guess. Does that mean that, I mean, would you say there's, what do you mean by there's no basic arithmetic? Students aren't learning how to add and subtract, or they're not learning the times table anymore? What does that mean, there's no basic
there's
arithmetic?
Been a fundamental shift that began in the late 80s. And it was guided by the National Council of Teachers of Mathematics, which is an association of math educators. And they made some very bold steps in redirecting math education that included a de-emphasis of the basic skills of arithmetic. It's written in the document.
Okay, and what did they propose instead? What was their vision? Their
vision was for children to grapple with problems that require elementary mathematics and to come up with their own procedures. There are standard procedures of arithmetic called algorithms. These are procedures that work every time in every case.
Okay, can you give an example of what an algorithm is?
An algorithm would be column addition, column subtraction,
where you carry the number the way,
and long division. Those are algorithms. Now, there are some alternative algorithms that in fact are stressed in programs such as Everyday Math, which is the program that was adopted in New York City. And some of these algorithms are fine. They aren't discovered by the children, by the way. They are usually instructed to learn these, such as lattice multiplication. And there's nothing particularly wrong with children learning these procedures, but unfortunately in programs like Everyday Math and Turk Investigation, those procedures are emphasized over and to the exclusion of the standard procedures that children will need when they enter algebra and beyond. Long division in particular must be learned in order to go into polynomial equations in algebra and on to calculus. It is not controversial. It must be there. And what is controversial is that in everyday mathematics, it's not there. It is not the procedure that is emphasized for the students to learn. So what does everyday math, I mean, its title Everyday Math lets me think that it's going to give students the things they need to use mathematics in their everyday life. Right.
Am I wrong?
Well, actually, in fact, it doesn't even do that, because in everyday life, children would need basic arithmetic skills to add up their purchases at a grocery store.
All right, so let's talk about this.
So,
I mean, does everyday math ask students to bring in a calculator, or do they add? I mean, where are we getting those skills?
Now, the thing about everyday math, there's a couple of things that make it the most controversial, although Turk investigations is even more controversial than everyday math.
Which is the one we're using in the New York City schools?
In New York City, we're using both.
Okay.
In Manhattan District 2, we're continuing with Turk investigations in number, data, and space, and the sister program, Everyday Math, is the one that the Chancellor chose. And the Everyday Math program has some distinct characteristics that make it extremely controversial and fatally flawed in the estimation of many, including seasoned math teachers, math professors, and parents whose children are going through these programs. The introduction of a calculator, which begins in the earliest grade, the use of the calculator, and the encouragement of the use of the calculator in times when you would expect the students to be learning, for example, in a multiplication exercise in 3rd grade everyday math. First of all, you work with a partner typically, and it will encourage or ask the student to find multiple ways to solve, for example, 36 times 7. There will be no encouragement to use the standard procedure for 36 times 7. There will be encouragement for the students to find several ways to solve it. It could be anything.
But that's not using the calculator.
And it says if there's a problem, check with your calculator. The calculator is a key component in much of the children's work, and to the point where it becomes obvious to parents in the upper grades their children don't know basic facts of arithmetic. Now, this is one of the red flags, is that a parent will see 3rd, 4th grade. That's usually where you start to know your multiplication tables. You start to use standard procedures. You won't be grappling anymore.
So are you saying that New York City school children are not learning the times table?
They're absolutely not learning what they need to learn, and it's quite evident from the assessments. Now, we know that we had trouble with our state assessments during the period of 2003 when Everyday Math was adopted through now. Once the test was re-leveled to a point that was reflecting the rigor that the state regents expected of students, we realized that the students really hadn't made virtually any gains in the entire time we've had Everyday Math. However, there's another assessment that's far more important and more reliable in terms of measuring math achievement in New York City and New York State, and that is the National Assessment of Education Progress. And remarkably, our students from 2003 to 2009 have not made gains in any measure. It is rather remarkable. In other words, if you pull out subgroups, the Latino, African American groups, or children in poverty versus middle-class children, none of these subgroups made gains. And in fact, they've fallen further behind from students like them in other cities.
Let's take a moment, because Jim Carney had the opportunity to go to the Courant Institute at New York University and speak with some math experts. Let's hear what they have to say.
Professor Sylvan Capel is a founding member of NYC Hold and teaches at the NYU Courant Institute for Mathematical Sciences. I asked him how he thought math education in the U.S. is today.
Inadequate. That's to say, there are efforts being made. There are some good elements in the program. Our universities are at a very high level in terms of the research activities and the training at the most advanced levels. But the picture in K through 12 isn't proportionate to that and compares unfavorably to many other advanced countries, and even to some not quite as advanced countries.
Why is that?
Well, there's been a history of lack of focus on it. Young people have not been as encouraged as they might be to focus on mathematics. Curricula are not as rigorous as they should be. Overall, the culture doesn't support it as much as it does in some other places. And I'd like to see that improved. You want to develop both kids' skills and their interests in conjunction with each other, because you need both in order to move forward in mathematics. And in fact, the issues in mathematics are more pointed than the issues in science education, because in science you can leave elementary school with just with just a general positive feeling about science, know what it's about without being able to do science, and you're still equipped to go on and even become a scientist. Whereas by the time you leave elementary school, there's actually a whole set of skills that you need to be on top of to be able to deploy when you get to high school and then further.
Dr. Fred Greenleaf is also a founder of NYC Hold and a professor of math at NYU's Courant Institute. He has a somewhat stronger opinion on the state of math education today.
I think math education is pretty god-awful, especially in elementary school. And if you want to know the reason, it has to do with curricula promoted by a certain division of the National Science Foundation and promoted by the National Council of Teachers on Mathematics. And it's based on a radical ideology that just doesn't work. It's called constructivism. And I've seen representatives of the NCTM say things as ridiculous as teachers shouldn't instruct. It's damaging to the creativity of the little children. Or the way children should learn mathematics is to discover it for themselves sitting around a rug in little groups. Now listen, it took 3,000 years to get fractions straight. It's a result, or the arithmetic of fractions is the result of a long period of development. Kids are not going to do this anymore. They're going to learn how to play the piano without practicing scales. And the thing that kills most students, as I know from my experience as director of undergraduate studies, is that they have terrible problems with basic algebraic operations. That goes back in turn to they don't know fractions or they didn't learn it right. And if you don't learn fractions so it's automatic, you're in the position of somebody driving a car who has to read the manual every time you want to make a right turn. You can't function that way. I really believe a lot of this begins with curriculum. If you have a good curriculum, a well-meaning teacher who doesn't know it can learn from the curriculum and actually do okay with the kids. The kids have books. Everyday math doesn't have a book. You can't take a book home. This was one of our critiques of the founder. We said, you're disenfranchising parents wholesale. There is no book. The kid can't bring a book home. He brings these little worksheets home, but no book that explains it. Parents can't work with their kids. In fact, they discourage parents. These programs discourage parents working with their kids because parents don't understand what these new programs are all about.
You mentioned the tests showing gaps in how all the minority subgroups are doing. Is there an achievement gap in math the same way there is in reading, and are white and Asian students doing okay in math?
Yes.
Now, are they doing okay with everyday math?
The little trick behind these reforms is you can put a program, an even worse program, for example, Turk Investigations, in a middle-class community, and you won't see huge achievement drops for the following reasons. One is parents will take up the slack. They will tutor. There's pervasive tutoring. As well, oftentimes parents have taught their children from early on. It's a cultural reflection of certain cultures that the parents will have taught their children basic arithmetic before they even entered class.
This reminds me somewhat of the reading issue, and that is that most of the studies have indicated that most students will learn how to read regardless of the program that we use. And the controversy arises in terms of reading with ways of teaching reading to those students who are not finding it easy to break that code. Again, for most students, the reason why we've been people always ask me, why do we have a different reading methodology for every decade? Because you know what? For most students, it really doesn't matter. They will learn how to read. But there's a group for whom there's a big achievement gap, and they're not learning how to read. Is it the same issue then with math?
To some degree. What is not controversial is the topics, the subjects, the content that's to be taught. We should be able to find agreement on the fact that arithmetic is important, that the traditional algorithms for addition, subtraction, multiplication, and division are non-controversial. Those should be in any program that we begin with. And then we can proceed into different ways to reach different children who have different learning abilities. But the content has to be there, and that is what's controversial.
Now, of course, if we're looking about how math used to be taught, I do have to say that I was recently in Macy's and there was a 20% off sale, and everyone around me I could see was having a really hard time figuring out what they were going to be paying with their 20% off. So it seems to me that as a nation, that as individuals, we really seem to have some severe math deficits. And I remember as a child going shopping with my mother, who is from Europe, and she went to the grocery store and she added up everything in her head while the gentleman was writing it on the brown paper bag, and she would say, boy, what's taking him so long? I never had that ability, even though I was a pretty good math student. I could never just add up all those numbers. So what do you think is happening with how children in Europe and Asia are taught math compared to how American children are taught math? And not just today, but even